Hello, I'm BJ at Seoul National University. In the previous video, I showed that limit 1 over n is larger than 0, casting a doubt on the proposition that the limit of a converging sequence is unique. In this video, I'll present a counterexample of the proposition that the limit of a converging sequence is unique, showing that the proposition itself is flawed. Cardinality is defined as the number of elements in the set, and cardinality of real numbers, or continuum, is larger than that of natural numbers. This was proved by Cantor, one by the method of nested intervals, and the other by diagonal argument. I'll challenge the second argument later. For now, let's say card R is uncountably infinite and card N is countably infinite, and we'll discuss it in more detail later. In the current theory, the length of Cantor set is calculated as 0 by the concept of convergence and limit, even though I challenged that the length is larger than 0. In the current theory, there is a product in Cantor set. There are uncountably many numbers in Cantor set, even if the length of Cantor set is calculated as 0. In fact, the cardinality of Cantor set is the same as the original interval 0 and 1. I'm not going to present the proof. You can look it up in the textbook or in Wikipedia. All endpoints of the segments in Cantor set are countably infinite. Thus, the number of segments is countably infinite. Thus, there has to be more than finitely many numbers within each segment, even if the length of the segment is calculated as 0. Otherwise, it leads to a contradiction that finitely many numbers of countably infinite is uncountably infinite. Then, let's consider a sequence of endpoint numbers in each step, leading to one segment at its limit in Cantor set. Cantor set may be said to have no segments because its length is calculated as 0. A segment is just a figurative term because there are endpoints and many internal points in each segment. In this example of a sequence in Cantor set rotated 90 degrees counterclockwise, it is 0, 1, 2 over 3, 1, 7 over 9, 20 over 27, 7 over 9, ... This sequence is a Cauchy sequence because it satisfies definition if for every epsilon larger than 0, there exists capital N such that absolute value of x sub m minus x sub n is smaller than epsilon for all m and n larger than capital N, and converges into the segment in Cantor set. Even if the length of the segment is calculated as 0, there are more than finitely many numbers between the endpoints in each segment at its limit. Therefore, this sequence cannot lead to a single number even at its limit. Thus, a sequence of endpoint numbers in each step leading to one segment at its limit in Cantor set converges, but its limit is not unique. Thus, the limit of a converging sequence is not unique. Limit x sub n approaches x, but is not equal to x. And I like to write like limit x sub n is close to x. and explains limit 1 over n is larger than 0. And I'll discuss an issue in Dedekind cut resonating with the above discussion at a later date. In the next video, I'll discuss the issue of infinity multiplied by 0. Please send me critical comments to this address. Thank you very much.